Hey guys, what is up? Hare Krishna everyone. Um, I'm Shourov, back again with a new playlist, and this is the new video of that playlist. And I am going to start a machine learning project in this series. So this video will be on a machine learning project from a very famous book called Hands-on Machine Learning with Scikit-Learn, Keras, and TensorFlow. So today we are going to actually explore the chapter 2 where actually I have already solved that problems, and I'm just making a video so that you can also learn something from this video. And I'm not gonna take so much time because time is valuable, so I have already downloaded the dataset, and let's go and start right from here. So I'm asking apologies to you from you guys that I'm here in live, completely raw without any edit, so there might be some uh, background noises. So hope you understand what I'm trying to say. So let's start this video. Okay, so let's open Jupyter notebook. We are here. So let's create a new file, notebook price. Fine. So first of all, what we need to import some important libraries that will be needed in future in this video. So I'm gonna import numpy as np, and pandas is also important. So let me turn off my air conditioner. Okay, so we can actually manipulate arrays of numbers by using numpy, and pandas is very helpful for exploring our data and showing our CSV files and manipulating it too. And yeah, okay, now let's go and load our data by calling read CSV from the pandas, and I'm gonna housing price.csv. So okay, yeah, typo. So now let's have a look on our dataset. So here is the dataset, and if you want you can go inside this dataset and see it in your Excel file or sheet file, Google Sheet file. And okay, now let's come back on the topic. So it has 20,640 rows, or the features. It has the rows and 10 features. So let's have a look on the info that the data types of is columns or the features. It has longitude, latitude, housing median age, total rooms, total bedrooms, population, households, and it's floating number except this ocean proximity. So let's see what is that. Oops. Okay. Oh, my bad. So it is the ocean proximity, which is actually telling us that this house is near the bay, or let's have a look on another thing. Info dot ocean proximity value counts. Oops. Value counts. So it has on our ocean island, near ocean, near bay island. Okay, so they're the values of ocean proximity. It's a categorical value. Okay, let's go and explore our data. So it has, okay, see, it has a missing value. Some missing balance is total bedrooms, so which we need to tackle. So if I'm gonna go for the dataset dot is not dot sum to see how many missing values are there on the particular features. So in the feature named total bedrooms, we have 207 missing values, which is not a big number. The case of where we have almost 20,000 samples, so it's not a big deal, but we'll handle it. Okay, and secondly, let's again have a look on the data set. Okay, data set, fine. So it has this 10 fields, fine, that's okay. So if I'm gonna go for the columns only, so here you go, fine, that's great. Now let's explore the data. So what I need, we need the data set to be here, and we need to split this data, fine. So we are gonna use from Scikit-Learn dot model selection, import stratified shuffle split, and I'm gonna go for split of shuffle split, or I'm gonna go for the n samples. I am going to use 2, and let's see how many options are available here. So let's open it up, and what we need to set is the test size. So let's go for 20%. Let's take the 20% of the whole or entire data sets. So okay, now what I need is the split, right? So okay, for train index and test index in split dot split. Okay, split dot split, and we are gonna use the y thing. The y thing is missing, right? So we need the y. So first let's get inside to the errors. So I'm gonna go for the train set is going to be dataset dot lock is train index, and test set is going to be dataset dot lock test index. That's okay, and it's asking us that y is missing, so we need to handle it. So what I need to do, let's go and create another one. We need to see the dataset history, fine. So this is the hist which we need to see. So let's go and use the 50, or yeah, it's 50. And fixed size is also important. Fixed size, which I'm gonna go for the 40 into 40. So it's too hot here. I need to turn on my air conditioner. So there might be some noises background me, so I hope you understand. Please consider it. So see how it is working, and I can see that it has a median income histogram that most of the values are the numbers are from 0.5 to 6 actually. So we need to we can actually categorize our entire data set, housings or everything according to this set. Okay, so what I need to do is let's create another one. So I'm gonna go for housing cat. For that I'm gonna go for here housing cat, and I'm gonna go for pd.cart, and it has this options. The first one is the data set, the median income, then I'm having the beans. So the beans are here. So what are the beans? Beans are solely responsible for the separation from 0 to 6. So I'm gonna start from 0 and 1.5, 2.5, 4.5, 5.5, 6.5, and 7. Okay, so or we can use something like p.nf. That's it. So but one thing is missing here, which is the levels. Make sure that levels must need to be on number less than the total number of pins. So let's go and add on to 6. 1, 2, 3, 4, 5, and 6. So here you go. Now if I'm gonna open up another thing to see what's inside our data now. So here you can see that it has a housing cat. The category is labeled as 6 in number, and let's see the first 3, and it has all 6. That's weird. Let's go for the first 10. Yeah, you can see that all the different numbers. They're not numbers actually, they're the categories. If you wanna see that, I'm gonna again import it. Print the information of the data types. So see, housing cat has been added here with the data type of category. Okay, that's great. Now let's come here, and we have the features. Here you go. We have the features, and you can use the y label. It's called datasets dot okay, income cat. Oh, my bad. It should be income cat. My bad. So let's go for income cat, and it has test indexed. This is not I was looking for. Now let's come up here and see the train set. Actually they're containing the indexes, individual or splitting indexes, and I'm gonna lock is kind of a array slicing here. Okay, so it's containing the all indexes, and facing from the data set, and containing inside the train and test set individually. Okay, so I'm gonna train set. Oops, my bad. Train set. See, it has this much of rows and 12 columns. Okay, 12 columns. Housing cat is here which should not be here actually. Okay, so that's okay. We need to drop this to now as our okay. Let's see the test set too. Yeah, see, it has this number. Okay, now let's go. Come here, and I'm gonna go with the for set in the, actually I think the range of our actually train set and test set. Oops. Test set dot drop what we need to drop. Actually we need to drop the these two values, housing cat and I'm gonna go for the axis is 1, which means it's a column, and in place true, that I need to permanently remove this feature of the column from here. And the second thing will be the income cat. Let's remove it, income cat, and if I'm here and see the train set dot head, then this two should be out. Okay, see, this is not here. So we used this income cat to just create a train set and test set by splitting it. Okay, we used these categories as our y, okay, or the levels. Y means levels. Okay, fine, so we have it. Now let's go and plot our the train set. Okay, train set. So train set dot plot have a kind of scatter, and what do you need? We have a x of longitude. Let's say it's a geographical data, so we can actually see that by this. See, here you go. Here's the data, and let's see which portion of the area contains more houses. So for that, I'm gonna go for alpha is, I'm gonna go for 0.1 and see, these are the areas where many points are. They are the warm points where actually more buildings or houses are exist. Okay, now let's go and see another thing that we need to use. Okay, so first of all, we did split them inside a train set and test set. Let's work on the test set now. We need to prepare them. Okay, so I'm gonna go for the train set. Sorry, we need to work on the test set, and I need to see how many null values are there. So here you go. We have total on 66 here in the train set. Or rest of the sets are, or the missing values are inside the test set. Here you can see that train. So let's keep it keep working on the train set. Okay, so actually why we are splitting them inside into two pieces are train set and test set, because our model, when we will start building our model, we'll use our train set to train that model, and well, we'll evaluate our model that it is working or scoring as our expected result or not. To test that, we need to use the test set on the model. Okay, so let's go and handle this. To handle this, we can use we can use Scikit-Learn dot import simple imputer. It's an imputer to handle numeric values. So let's see. Keep in mind that simple imputer only works on the numeric fields, so we need to remove this thing from here. But instead of removing, we'll create a new set, num train. Okay, num train set. So I'm gonna go for the train set. Train set dot drop. Yeah, drop. Yeah. Proximity. Axis is 1, and num train set. Here you can see that there is nothing called Gaussian proximity here. That's okay. Now what we need to fill is now dot sum. We need to fill this this number of missing values. Okay, so they're the bedrooms. So I need to create an instance of simple imputer simple imputer strategy. I'm gonna use the median value. So here we go. And what I need, imputed num train set, and to use imputer dot fit transform. See, the y level is not recovered here. We need the only features, which is x. So what we need to just copy this and paste it here. And let's see the imputed train set. Here you go. We have this thing, and now let's see it in a visual way. So pd dot data frame, and where is the data? See, and to see, okay, so at the columns I can use the imputer dot feature names in. Yeah, that's it. Feature names in. Yeah, okay. So the noise is very loud behind me, so please consider it. And I need to use the isna dot sum. See, there is no missing value exist anymore here, so we handled it pretty much well, but we will not use this data. Okay, second one is that machine learning or the computer don't know how to handle the strings and the objects, so we need to convert them into numbers too. But before that I would also like to introduce you the standard scaler to convert these numeric values between 0 to 1. That will help it's a normalization, and it helps us to make better accuracy models. So let's go and import from where? Pre-processing, my bad. Pre-processing, import standard scaler. So I'm gonna scaler and standard scaler, and I'm gonna go for the parse. So sparse standard scaler. Okay, that's it. So I'm gonna use the transformed. Okay, imputed normal train set, and I'm gonna go for the scalar, and the scalar is going to have dot fit transform the data from here. So I'm gonna go for the imputed num set. That's it. Or I can also use it as a imputed df, or means it is the data frame, so that we can use it. Let's copy it and paste it here, and imputed normal train set, and it's actually not working here. So it has the array, 2D array got on the array, fine. So it's on the array. Yeah, that is the problem. This is on the array, so I need to handle it. To handle it, let's test out this thing. Yeah, it is working now. So see, we actually need to use this array instead of this. So we can simply remove it and have a look on the data frame. And we can use it inside another data frame that is actually the transform. Okay, it's a data set, so I can simply name it as a df as, let's again convert it inside a pd dot data frame, and this thing with columns of, okay, scalar dot features in, yep, scalar dot features out, maybe, no, scalar. So I'm gonna go for imputer dot feature in and imputed normal value df. So see how it's working now. It has been they all are transformed from between 0 to 1. Okay, so yeah, that's what we were looking for. Now let's come here, and we need to handle another thing, that the text one. So to use to convert that, let's come here and use it like, okay, so Ocean proximity is going to have a train set Ocean proximity. See, they're the values. So let's go and import pre-processing port on hot encoder, and then the categories that are see, let's have a look here. Okay, what I need to remove this sphere, you can use it as false. That's all I was looking for. Now, yeah, let's go and use dot fit transform transform, and I'm gonna go for, and it's not a 2D array, it's on the array now. So let's get inside into a, let's face a euro. See, it's a euro, and it's asking that it's not it's on the array, expected 2D array. So let's make it 2D array. Yeah, see, it's now working. So on-hot encoder actually divided them into new features, and let's say it simply like this way, that if it is has this house is less than 1 hour from the ocean, then this feature will be contained on, and rest of the other 4 features will be 0. So this is the simple understanding of this feature on hot encoder. Okay, see, there, that fine. So now let's go and combine them all. To combine them all, we can use a pipeline. I'm gonna go for this learn dot pipeline import pipeline. So it's a pipeline. I'm gonna use another thing. So it's a num pipeline. So num pipeline, pipeline, where I'm gonna use the pipeline, and it has the steps. That's what. And these steps expect tuples of array. Now I'm gonna name it like, first I'm gonna impute it, imputer. So standard scalar and strategy. Sorry, it's a simple imputer. And strategy, I'm gonna go for meeting, and then I'm gonna go for the scalar. So standard scalar. Okay, that's it. And if I'm gonna go for the num pipeline, where we can use dot free transform, the x is required to transform and go through the steps. So to use it, we can use a num free transformed. Let's come here. This is the last thing we had actually. So let's use it, and here we go. See, actually this is not need to use, this is already transformed, so we need this thing, num train set. So everything will be transformed from that. See, yeah, it's transformed. Okay, now let's keep it inside another thing, transform train num data, and I'm gonna use it as pd dot data frame. Yeah, I'm gonna go for the transformed name data. So it has this thing here, and what do we need now to see it's working quite well. It's not a problem, so that is okay. Now let's go and use another thing, which is the column transformer. Import column transformer, and I'm gonna go for the call transformer, and I think it's having some problem, maybe call transformer, and I think it's crashed. Let's reload it. Yes. So fine. So this thing is not exist anymore here. That is why it's giving us the error. Yeah, that's okay. Now let's go from Scikit-Learn dot compose import column transformer call transformer. It's going to be column transformer, and yes, it will have something. Let's open up the documentation. So we need the transformers. So in the again, this is the transformer where we need to use the pipeline to work on. So I'm gonna go for num pipeline and specify the column names, right? So they're really important. To do that, I have an idea. Let's go here, the num feature names. I'm gonna come from here. So num feature names, not like that. Let's have a look where it is. So let's see, train set dot columns and the num features. Here you go. So I need from first to -1 so that the Gaussian proximity is not included. See, so I'm gonna use this method to remove that, and I'm gonna go for another thing called Gaussian proximity, where I'm gonna use Gaussian proximity. Actually, I'm creating a separate column name that can be used later on. Fine, so these are the features or the column names where it will log, and another one will be the on hot that we had created previously. So I'm going to go for on hot encoder and sparse is false, and the name will be the feature, or the column name will be this thing, and it has another thing called the reminder, and I'm gonna go for the pass through. Yeah, that's it. So I'm gonna go for the call transformer dot fit transform. So we do not need to now we do not need to drop the Gaussian proximity that was a string. Now we can directly use the train set here. See, great. Now okay, fine. So now let's come here and see the data frame of this transformation. That's great. They're the categories, okay? The Gaussian proximity, that 5 values are here, and the Gaussian proximity column itself has been dropped. So this is the thing. Fine. Now what? Now we need to select everything, right? But we did a mistake here. So what mistake we did? So let's go here. We had the made in house value. That value we need to predict, right? So let's come here and yes, where we need to use it. Okay, here before pipeline, I'm gonna go for the x means the features. Train is that for the train set, so I'm gonna go for the train set, and I'm gonna drop the main house value access 1, and y train, I'm gonna go for the train set, and this will contain the made in house value. See, let's have a look. Dot head 1. So yeah, that's okay. And if I'm gonna go for the y, here's the value. That's okay. That's what I was looking. And the housing value is also not required here, the feature names. So to have a look on the name, I need to use feature names. So this thing also need to be dropped from here, so I'm gonna go for this too. That's great. Now perfecto. So yes, and this is not going to be a train set, so I'm gonna go for the x train now without that value, because that value need to be predicted by us. Okay, that thing is dropped now. Okay, now there are several models built by Scikit-Learn, so I'm gonna use the random first. Scikit-Learn. So Scikit-Learn, so Scikit-Learn maps. So if you go inside this Scikit-Learn maps, see that it has a clean sheet. Start, we have more than 50 samples, and it is not categorical, so it's predicting a quantity. We have less than 100k, and I have already tested this models, so I will use the ensemble regressor here. So let's go here, and where we are now, yeah, here you go. See, and let's go and import the models from Scikit-Learn dot ensemble, import random forest classifier. Oh, sorry, not classifier, it's a regressing thing. So I'm gonna here, so forest reg is going to be random forest regressor. Yeah, that's it. And now let's go with the forest reg dot, sorry, now let's fit the model. So I need the x train, and let's give this to, and yeah, we got a problem. Narrow chain. So this is actually having problem. So okay, I got it, because I need to use this thing, right? So the model cannot use this string types. So let's come here. We need to see it here, that transformed x train That's it. Yeah, we need to use this thing instead of the raw train feature. Yeah, so let's give it a time to train itself, and yeah, it's done. Now let's predict it. First take the predict, and I'm gonna go for the Y train. Oops, it has on the array, expected to the array. Yeah, the Y train is having some problem actually. That's okay. Let's come here. The Y, where is the Y? It's the plotted. And num pipeline before that can actually use it. Oops. Yeah, that's it. Oops. I got it. Okay, so we are doing a very slight issue. So the issue is here. Yes, it is working. Now let's have a look at Y train. Y train is good. Okay, print Y train. Yeah, it is working. This is what, but we are not actually using this thing, so I'm gonna go for the, it is completely okay. It's 2D array, so I need to predict the Y train from the X train. So I'm gonna go for the test the X train now. So this was X train, this is not X train. Okay, this thing, I'm again missing something. Okay, and let's see the first 5, and there the Y value is actually predicted from the model, and I'm gonna go for the cross validate it by using this, and see they're pretty much near, not exactly accurate, but okay, that can be runnable. So let's use it. Can use our first rate dot score. I'm gonna go for the transformed X train with the Y train, so it has 97% of accuracy score. Okay, now that's fine, but yeah, I'm gonna go for another thing called a Scikit-Learn grid view. It's too hot now here. So grid source view is very important, and it's inside the model selection that can help us to fine-tune our model. So I'm going to go for import from Scikit-Learn dot model selection, import grid source CV, and now I'm going to go for the source params. That source params will be a list. Is that a list? Let's see. Yes, it's not a list. It's a object, or yeah. So what should be inside here? To see that, let's go and re-register our model. See, we have a very huge number of parameters inside here. So I'm gonna go for the estimators. you can search it here by 1, 3, 3, 8, and 100. And we can use max features, max samples, bootstrap, samples. Okay, let's go for the max features. Two, 3, 9, 8, 11. That's okay. I need to use them, and I'm gonna cut it. Oops, they are actually strings. Fine. Now let's come here. I'm gonna go with the grid source. It's going to be grid source CV, and it has the estimator. The estimator is called, okay, before that we need to use another thing called forest forest reg. It's going to be random forest regressor, and let's open up the documentation of grid search CV, and you need the estimator, which is here, and the param grid, which is for our case testing. The scoring, I'm gonna go for the neg, cross card error, and what are there, that's CV. I'm gonna go for 10, yeah, and grid source dot fit. I'm gonna go for the transform this thing with y train, and we're in error. So we're in error now. Okay, so I need to use Scikit-Learn fine. Okay, so it's minus card here, my bad. Minus card here, and it's fitted here, I think, but it's not yet fitted. It's still finding, I guess. Okay, let's have a look here. Not this one. Here you go. So it's arcing actually. It's still arcing. There are the few features that are arcing there. It's too hot. I need to again turn on my air conditioner. So let's give it a time to complete it, or I think the n number, what it is indicating. So let's come here. So it's ambulance sound. Oh God. So it is still working. Very amazed on it. Let's see. What I can do is that let's make it 1 and 1 3 for simplifying our target. So I'm gonna restart it. Let's do it from here. Rerun everything. So it's a huge data, you know. So you're almost at the end of the project. So let's see how much time it will take now. Yeah, that's okay. We are working on it, and it's okay. Careful cross validation requires at least on train split by n splits 2. I think it's having a problem that n splits two. So let's go and have a look. We cannot use it on, we can use more than on, okay? And it's arcing. Let's wait and watch. Yeah, it's done. So we have this, and I'm gonna go for the grade search dot best params. So they're the best numbers, and let's see the accuracy. Best score. Okay, that's good. And best estimator. Fine. So we can use it by, let's see the other options to see the results, and results dot params. Not like that. Yeah. So let's see the best results. Best params. Okay, they are the things. So I'm gonna go for the random forest rig. I'm gonna go for the, it's going to be random forest regressor, and it has an estimators of 100 and max features of 8. They're the hypertune. They're the tuning of the parameters of random forest, and it's an instance of that regressor model. Now let's come here and use something spatial. I'm gonna go for the pipeline here. So model pipeline. I'm gonna go for the again pipeline, where I'm gonna use the steps, and step will be here, the transformer, and it will be the call transformer. yes. And the second one, I'm gonna go for the model forest rig. And what is that? That is this thing. I need to copy and paste it here. Yep. Now let's see the model pipeline. See, so this is the pipeline. First it will impute and fill the missing values, then it will standard the scale, the values, number values from between 0 to 1, then it will handle the categorical data and other data left that will be passed through, and then it will come inside this random forest. Now see how simple it is working now. So we have the test set generated before. Here's the test set. So it has the made in house value. So I'm going to go for the x test. This is going to be test set dot drop made in house value, and I'm going to go for the x test. Oops, should be access on. Here we go. And that is dropped. And y test, I'm gonna go for test set and made in house value, and y test is going to become here. That's again great thing. That's perfect. Now they're here. X test, fine. See, they're not transformed, they had these things, but I'm gonna go for the model pipeline dot fit transform, and I'm gonna go for the x train first and y train. So it is gonna train, and see, it has no attribute called transform. Fine. So I'm gonna go for the fit, only fit. Yeah, that's it. So before that, I also need to see the x train is actually having everything or not, because we did a lot of manipulation there. So yes, 1 2 3 4 5 6 7 8 9, 1 2 3 4 5 6 7 8 9, everything is okay. Now let us go and use this thing. In the model pipeline dot, see, we didn't use the number or anything, it's already gone through is the steps, and here, and I'm gonna go for the predict now. The prediction, I'm gonna go for the same thing, which is the x train, and here's the predictions. Fine, okay. They're the predictions. Now I'm gonna go for the y train, and here are the predictions, almost near everything. See, that's a great sign. Now it's time to predict our x test. Here's the x test, and I'm gonna go for the y test. See, this is not so great, but almost come to each other. That's okay. Now let's go and see what we have gone through. It's a long process, see, and yeah, we did a pretty good thing. And I'm gonna go for predict, or I'm gonna go for the score. I'm gonna use that same x test and y test. See the result, it's 80%. Okay, so this is for today. If anything yes, obviously the result can be more promising, but we can do it in later sessions, the upcoming sessions. I can do it on live. Okay, so if you like this video, please make sure to subscribe this channel and share this video with your friends and those who are start learning machine learning. So yeah, I know this is not the perfect tutorial, but I hope it gives you a clear view of machine learning and how easy it is to learn it. And make sure to like this video, and yeah, bye bye. Every link will be described down below in a few hours. Okay, goodbye. Hare Krishna.